Assalamualaikum and good day. This is the part 3 for limit as x approaches plus minus infinity. In this one, it will involve radical. Okay? For example, the first one, rational function in one radical, which means limit root of px over qx in one radical as x approaches plus minus infinity. Okay, this in under the same radical. Okay, for example, the first one, we have limit root of 2x cubed minus 4 over 5x power of 3 plus 1. Okay, so right now, we still need to use the rule of thumb. Okay, let's look at the highest search for the highest power in the denominator, and that will be x cubed. That's why here, every terms in the numerator and denominator need to be divided by x power of 3. The highest power only, not including the coefficient. Okay, so here 2x cubed divided by x cubed minus 4 over x cubed divided by 5x cubed over x cubed plus 1 over x cubed, and this one remains limit x approaches positive infinity. Next, what you need to do, you need to simplify. So here it's going to be 1, and so that's here. Okay, let's look here. So next, you just need to substitute the value of positive infinity in x. Okay, we have 2 minus 4 over positive infinity cube divided by 5 plus 1 over positive infinity cube. Okay, for this 2 is going to be 0 because anything divided by infinity is 0. Okay, and therefore the final answer would be negative root. It's going to be root of 2 over 5. Okay. And then let's move to the next one. We have here, okay, determine limit root of 3 minus x squared over 2x power of 5 plus 8 when x approaches negative infinity. Okay, so we need to search for the highest power in the denominator, and here it is x power of 5. Therefore, every terms need to be divided by x power of 5. Okay. Just simplify wherever you can. Okay, here it's going to be 1, 3. Okay, 1. Then substitute the value of negative infinity in x, in all x. Okay, so here root of 3 over negative infinity power of 5 minus 1 over negative infinity power of 3. Remember to simplify before substitute the value of x. Okay, remember to simplify. Okay, because you will never get the terms infinity over infinity again here unless you haven't simplified before that. Okay, please remember simplify before substitute the value of x. Okay, so right now this one gonna be 0 because anything divided by infinity is 0, and so does in the denominator. So we are left with root of 0 minus 0 over 2 plus 0, and here is gonna be root of 0. Root of 0 is 0 again. Okay, next. Okay, in the case of limit px over qx when x approaches plus minus infinity, px or qx involves radical. Okay, we need to divide the numerator and denominator by the highest power in the denominator too. Okay, let's say in the case of you have the highest power in the denominator as x. Okay, so here you need to divide the numerator and denominator by modulus of x, where this is fixed, a theorem. Okay, nothing can be changed for them. Okay, which means root of x squared is equal to modulus x. Okay, and then as x approaches positive infinity, so the values of x under consideration are positive. That's why we replace modulus x by x. And when x approaches negative infinity, we consider the negative value of x. That's why we replace modulus x by negative x. There's a reason behind it, because this is modulus x, which means it's always going to be positive. Okay, positive infinity, let's say, because this one is plus minus infinity modulus. Okay, so we will need to consider the positive and also the negative value of x, which means here we consider the value of infinity and also negative infinity. Okay, negative infinity, modulus gonna be infinity. Okay, because negative times negative infinity is positive infinity back again. Okay, so right now, for example, let's look at the first example first. Okay, determine the limit for root of x squared minus 5 divided by 3x plus 1 when x approaches positive infinity. Okay, here we need to look at the highest power in the denominator, and it is x. Okay, as I mentioned earlier, if the highest power in the denominator is x, you need to divide everything with modulus x. Okay, where modulus x is equal to root of x squared, because both of the answers can be positive x and also negative x. Okay, this is a theorem. Okay, we need to follow this. Okay, and then okay, since both of them, so numerator and denominator need to be divided by modulus x, so therefore you will need to change this part. Okay, instead of modulus x, in order for it to, we want to combine with this root. Okay, that's why we change modulus x into root of x squared. Okay, next simplify. Okay, this part here, since x is approaches positive infinity, we open the modulus x as positive x. Okay, as you can see here. Okay, positive x because we refer to the limit given. Okay, that we need to determine. Okay, so here combine them in one root. Okay, remember root a over root b, as long as the power of the root is the same, we can actually combine them into this. Okay, for this one, remember to divide each term separately. Okay, as you can see here, I did it separately. Okay, next just simplify. This would be 1. Okay, and then just substitute the value of x, which is 1 minus 5 over positive infinity squared, root of them, over by 3 plus 1 over infinity, and anything over infinity gonna be 0, and hence we have the final answer as 1 over 3. Okay, next example. Okay, but right now we'll be looking at negative infinity. Okay, here what we have is limit 2 minus x over root of 5x squared plus 4 when x approaches negative infinity. The highest power in the denominator is, as you can see, the highest power in the denominator is actually x squared, but it is in root, which can be written as this. Okay, so root of x squared is equivalent to the same as modulus x. Okay, that's why here I didn't divide the numerator with root of x squared, but instead I divide it with modulus x. Okay, remember this is a theorem. Okay, and then limit x approaches negative infinity. For this function gonna be 2 minus x divided by modulus x. Everything divided by root of 5x squared plus 4 divided by root x squared. Why? Because this is the highest power in the denominator. Okay. Okay, next we need to simplify. So we want to combine the denominator in one root. So it will be like this. But for the numerator, you need to refer to your limit. Okay. Since the limit is approaches negative infinity, that's why we open the modulus x as negative x. Okay. I repeat once again. Since the limit here is x approaches negative infinity, we open the modulus as negative x. Okay, remember to write separately. Every term, divide each term separately. Please remember to do that. Okay, it will help you a lot. Okay, right now, next simplify. X divided by x gonna be 1, negative and negative gonna be positive. Okay, and therefore we have limit x approaches negative infinity, open the bracket, negative 2 over x plus 1 divided by root of 5 plus 4 over x squared, and then close the bracket. Substitute the value of negative infinity in x. We have negative 2 over negative infinity plus 1 over root of 5 plus 4 over negative infinity squared. Anything divided by infinity gonna be 0. Okay, and hence here it will be 0 plus 1 divided by root of 5 plus 0. And the final answer is 1 over root 5. Okay, we are approaching the end, the last part, okay, which is this one. Okay, limit x approaches plus minus infinity, root of px minus qx, or limit x approaches plus minus infinity, px minus root of qx. That means one of them involves radical. Okay, as you can see here, let's say when for this example, when we substitute infinity, it's going to be infinity minus infinity. Please remember, infinity over infinity does not equal to 0. It is still indeterminate form. Okay, as you can recall, okay, I hope you still remember last week, okay, in previous class, sorry, we did discuss about the indeterminate form when there is radical, we need to multiply with the conjugate. Multiply with conjugate. So here we will do the same. We will multiply this term with its conjugate. Okay. Next, the conjugate will be negating the second term. So we just need to change the sign negative into positive. Rewrite everything but change the sign negative into positive. And one more, remember, nothing changed in the radical. I repeat, nothing changed in the radical. It will be the same as earlier. Okay. And then, next, okay, expand. Okay, we expand. Since the one that we multiply with the radical is numerator, so just rewrite everything in the denominator. Nothing changed there. Okay, for the numerator, okay, I hope you didn't make any silly mistake when multiplying these terms. X power of 4 times x power of 4 is actually x power of 4 plus 4. So the answer will be x power of 8. Okay, x power of 4 squared like this does not equal to x power of 16. It is actually x power of 8. Okay, this one is correct. Okay, this one does not equal to x power of 16. Okay, so next, this one is x power of 8 minus, okay, remember as this is a negative, everything behind it should be in bracket. Okay, remember to write it in bracket here. Okay, compulsory. Okay, compulsory. Next, simplify. We have this equation, this term, because x power of 8 minus x power of 8 is 0. Minus minus is plus, so 3x power of 6. And here, if we substitute the value, it's still going to be infinity over infinity, which is indeterminate form. And here we apply the rule of thumb again, because we need to solve this question. Okay, so it does not end here. Okay, so you still need continue. You still need to continue. Okay, the highest power in the denominator is x power of 4. So every terms need to divide by x power of 4. Okay, including this part in the radical. Okay, x power of 4 is actually equal to root of x power of 8, right? Because x power of 8, 1 over 2. So, sorry. It will be x power of 4 again. Okay. And then, for this one, you can simplify right away. It's going to be 2. This is going to be 2. Okay. Here 1. And for this part, you need to combine them in one radical. So, it's going to be like this. Okay. And then simplify. Okay. Then only substitute the value of infinity. So here is going to be 3 times positive infinity squared over 1 plus root of 1 minus 3 over positive infinity squared. Okay. So here, if we substitute the value, what we're going to have is actually like this first. 3 times positive infinity divided by 1 plus root of 1 minus 0. Because this one going to be 0. This one is not 0, okay? It's multiply, not divide, okay? And then 3 plus positive infinity is positive infinity. And here 1 plus 1 is 2. Positive infinity divided by positive 2 is going to be positive infinity. Okay, that's it for this video. The last part of limit at infinity. Thank you. Hopefully you understand the whole thing about how to solve limit at infinity. Assalamualaikum.